Hello, everyone. Thanks for joining us. This is Mark Dempsey with the National Convergence Technology Center. We're here at HITEC today to share with you new perspectives and projects from some of the students in our program. Student posters have become a tradition for us. Here's photos of some past HITEC conferences. Typically, we bring 2 or 3 students to the conference to showcase their work. Usually it's a capstone or a group project of some kind. We didn't do this last summer, but we decided to keep the tradition alive in 2021, even though we're all still virtual. So here's a quick word about us. The National CTC is based here at College College in Texas, just north of Dallas. We are funded by a grant from the National Science Foundation. We started as a regional ATE center in 2004, and ATE stands for Advanced Technological Education. Then we became a national ATE center in 2012. We're currently in our renewal grant as a national center. The CTC's mission is to support IT infrastructure and cyber programs across the country by helping align curriculum with workforce needs. All of our work is led by our national business leaders, the group we call the BUILT, and we also manage a community practice of educators from 83 colleges across the country to facilitate the sharing of resources and know-how. And it's from that group of colleges that these students come. Today we'll be hearing from David Graffeo from Sinclair Community College on the topic of quantum computing and encryption, from Matthew Shillinger from Lansing Community College, talking about a video he created for Security Plus Final, and finally from Henry Middleton from Gwinnett Technical College about the National Cyber League.
Hi, everybody. My name is David Graffeo. I'm a current student at Sinclair Community College in Ohio. A little bit about me. I have a background in computer science, my bachelor's degree in computer science from Oregon State University, and currently I'm studying cybersecurity. I've been in the tech field for a long time now, probably 10 years or so in various roles. And quantum computing and encryption has always been something that I've been interested in personally, because I keep hearing over and over how quantum computing is going to destroy encryption and how nothing is going to be secure anymore. And so I thought maybe I'd take a look into it, and been asked to share my thoughts. So here they are. So this is a brief look on how quantum computing technology can change the way we do encryption. But a little background on quantum computing itself. Traditional computers use electricity to represent data. The presence of electricity in a register is a 1, and the absence of electricity is a 0. So that's where we get the binary computer language, 1s and 0s. I'm sure many of you have seen it or heard of it. So it all comes down to the physical aspects of the chip and the motherboard working together and using these 1s and 0s to do things. Quantum computers, on the other hand, don't necessarily use electricity. They use subatomic particles. They detect the state of subatomic particles, and those represent the 1s and the 0s. The state of these particles can change faster. Many more gates, as they're known, can be included in the same area that a traditional processor has. So you can have more data throughput would be the best way to put this. It's more compact. There's a size limitation when it comes to transistors for electricity, but for subatomic particles, that is not the case. You can make things much smaller. And there's a well-known thing in computer science called Moore's law that states the number of transistors will double every 2 years. But 3 nanometers for a transistor is theoretically the smallest that it can be. Any smaller than that, and electricity won't be able to flow properly through that transistor, and the whole thing breaks down. So the push for quantum computing in recent years is mostly due to that. We're rapidly reaching that 3 nanometer size in our transistors, and might even be there now, but if not, it'll be very soon. So quantum computing is definitely the way of the future, and if we want to have our computers get any faster, it's going to have to be quantum computing. So encryption itself, it relies on prime factorization. It's a bit of a math thing. Several large prime numbers multiplied together, and the product is used as a public-facing key. The recipient knows what those prime numbers are, and so are able to compare it to the number that they received from somebody else. The problem there is calculating prime numbers is a difficult task. You got 3, 5, 7, 11. It's easy to do those, but when you get into the hundreds of thousands or millions, trying to figure out what is a prime number and what is not is incredibly hard and resource intensive, because you have to divide that number by every smaller number that came before it. But being supplied that information, you can quickly and easily determine if something that you received is using that factor. For example, let's say my public facing keys were 5 and 7. I multiply them together and get 35. So anything that I encrypt using the number 35. And then somebody receives that data and I tell them that it's encrypted using the number 35. And I supply them, if I trust them, the keys 5 and 7. So they're able to accurately and quickly tell, okay, yes, 35 is a product of 5 and 7. I trust what this is and I can decrypt it. If I don't have those keys, on the other hand, I have to look at 35 and say, all right, is 35 a prime number? No. Is 34 a factor of 35? No. Then you have to go through all the rest of the numbers and try and figure out what it is. Now, this is a simple example because I'm not a math genius, so I can't come out with large numbers off the top of my head, but I'm sure you can see that this becomes very complicated very quickly. And reversing the process without the keys is very difficult right now because our computers are not fast enough to do it in a timely manner. Quantum computing doesn't actually solve that problem. It just does it faster. Encryption relies on the computation difficulty of finding those keys. RSA and ECDSA and some other algorithms will not be safe when quantum computing is commonplace because the prime numbers and the keys used in those encryption algorithms are not big enough. The potential number of keys that it could be, while right now would take a very long time to figure out, for quantum computers, it would be very, very quick. Unfortunately, right now, these algorithms are used to protect web pages, emails, and a lot of other common applications that we use on the web. So when quantum computing comes out and is more commonplace, these applications will no longer be secure. However, not all algorithms can be broken by quantum computers because some are much more complicated. The AES 256 and other longer key algorithms are safe, but they're rarely used today because of their complexity. So we will probably see a switch from simple RSA encryption to the AES 256 or better for all applications. Quantum computers are a ways off for most people. And as said before, they're not adequate for more complicated encryption methods. The simpler ones will be discarded. This is just looking at quantum computers as they are today. Theoretical quantum computers, I suppose. We might even, after their inception, figure out how to make them even more powerful. And then the AES 256 will no longer be secure. So it's an evolving field. It's very interesting. And for now, we are safe. But when quantum computers become commonplace, we're going to have to step up our encryption game. So that's about all I have. Thanks.
So my name is Matthew Shillinger, and I made a project for my Security Plus preparation course. Presentation I was supposed to make was just basically an inventory of a network, explaining the devices that were on it and the vulnerabilities that might be present within those devices. And so instead of just presenting that information in a document form, I decided to make it into a skit. And so I recorded a video where basically vulnerabilities were leveraged and an exploit was carried out against a network that was not very savvy in the way of security, although their employees were very handsome. We had to have a document of just explaining what the devices are on the network. So we were given a topology, and we basically just had to decide on our own, like what this device actually was, what operating system it was running, what the hardware manufacturer was, and then do research onto what may be some vulnerabilities that could be exploited, or maybe just inherent to that technology that someone might use. And so we had to make a list and document, showing what those were. And then we had to go and show the likeliness that those attacks might actually be carried out. Some of them might require some great technical skill, or just, maybe they wouldn't be bothered with because they were just not that great of an exploit to begin with. And then we had to go and explain how you might overcome this vulnerability, whether it would be mitigation, Maybe you have viruses that are a problem, so install an antivirus, or you have outdated software. Well, update the software to make sure that that vulnerability is no longer present in that code. Or maybe you're just going to accept the risk, so that would be an acceptance. Avoid the problem by just getting rid of it altogether, and things like that. So explaining what you would do to make sure that threat would no longer be an issue on your network. This is my first peer security class. All the IT classes I've been in, of course, there's been a focus in cybersecurity as well, but this was the first one that fully focused in on that. I've also participated in some capture the flag events, so I'm trying to get a lot more understanding and experience in the field through different avenues. So it's something that I'm really interested in and passionate in, and I want to continue to learn in this avenue of technology. I'm also really interested in networking too, but I feel cybersecurity, wherever you're working in IT, that's going to be something that's going to be very prominent. That's going to be needed, especially now there are so many cybersecurity exploits being carried out. You hear about them all the time, and so I feel like that's a real asset to any person in IT, and a company should really be focusing on making sure they have a solid cybersecurity program in their organization. Well, I learned about lots of different interesting vulnerabilities. Some that were just wacky, like one that the character in my video used was basically there was a vulnerability on a Linux Mint server where all you had to do was press the menu button and it would unlock it. So that was interesting to find out. I looked all those up on, the CVEs on the website that lists the different exploits that are known, right? And so, yeah, it was very interesting to find these different types of vulnerabilities that could be used. Now, it's been patched, of course, since that was pretty critical, right? So, but just to see all the different types of vulnerabilities that could exist and can exist. The more I learn more about cybersecurity, the less safe I feel. I used to think, I've got an antivirus, I've got firewalls, I'm good. Nobody's gonna hack into my system, but it's obvious that if someone's persistent enough, they know enough, they're gonna get in if they wanted to. Hopefully I'm of no importance, which I feel is true. So they're not gonna bother too much. Obviously there's malware and stuff that just goes wherever it wants, but as long as I'm not being fully targeted, I think hopefully I'm okay. But still, you got to be real careful about all these different things. Whatever it might be. Use a VPN when you need one on an untrusted network, or even on your own network. Basic things like that. It was overall received well, and I think it did well at showing how a threat could be utilized, or a exploit could be utilized to gain access into someone's network or server. And so it was kind of interesting. I really liked the way it was done. Well, I had the idea rattling around for a while, thinking about what I might do. And I didn't know if I was really going to go through with it or not. And then I started telling people about it, and they're like, yeah, you got to do it. So I was like, all right, I'll do it. So it took me quite a while, pretty much the whole day. The audience obviously was my class, but I do feel it is beneficial, as you said, to really see how this really could take place. You don't want to throw important documents away in the trash. People will go in the dumpster, find those. We learned about that. You hear about that. You need training of your employees to know that in the first place, right? So that's something. You need social engineering training for your employees, so they know not to let somebody in the front door, and make sure you know where they're going and not let them wander around and find the server room.
Right. Yeah, right.
Things like that. So yeah, definitely. I think if you look past the silliness of it, it really is I think a video for learning, really, on how to avoid these issues.
My name is Henry Middleton. I'm a cybersecurity student at Gwinnett Tech in Lawrenceville, Georgia. And today I want to talk about National Cyber League, which is an ethical hacking competition, or also you could say you're getting practice in red teaming, which is the practice of actually attacking a network, as opposed to blue teaming, which is the practice of defending a network. And it is an important skill for people in cybersecurity to know about, and really for anyone in IT to know about, because you have to defend the network, and so part of that is learn how a network can be attacked. And so an NCO, it's just a competition for the students can engage in so they can learn various methods of attacking the network and learn the various tools that are used. So you could say that NCO is a performance-based cybersecurity competition in which, well, you perform network reconnaissance, scanning, ethical hacking. It gives you practical experience in these skills. And I'd say it gives you experience with them beyond what you learn in the classroom, which is really cool. I mean, it's not just reading about them. I'm looking at some pictures in a textbook. You actually take part in these attacks. So, and it's really simple to get involved. I mean, you just go to cyberskyline.com. I know last season it was $35, and the one before that was $35. I'm not sure what it'll cost this coming year semester, but I imagine it'll be the same. So it's not expensive. And for the experience you get, I think it's well worth the price. And you can also connect with coaches. I remember there were something like 4 or 5 different people at my school who were coaching us along the way. And one of them was also a professor, one of my classes this semester. And you first start out by going to the gymnasium, which is a bunch of exercises that give you experience in the kinds of things you'll do in the actual game. And you can practice and learn. And there are help files that explain things along the way. And then you get into the actual game in which, well, you're on your own. You have to take what you learned during the gym and get into some real challenges. And so as far as why participate, I'd say really participate mainly because you gain experience with ethical hacking. And that's the reason I did it. I mean, I did not have any experience before I got involved, but I did it anyway. And you learn about key concepts in ethical hacking. You learn, well, that's stuff like open source intelligence. And I mean, I deal with that at work. I do tech support for cell carrier. I talk to customers a lot about using good passwords, not using things like their dog's name in their password, because, well, with open source intelligence, that's something people can discover about you. That's something they can look up on you. And open source intelligence teaches you about that. You learn about reconnaissance, you learn about scanning networks, such as you record the traffic and see what you can gather from that traffic before attacking the network. You learn about log analysis, learn about password cracking, for example. It was through NCL that I learned about a certain tool that can be used to crack zip files, and I demonstrated that in a class project I did on computer forensics. You learn about enumeration, learn about computer forensics, web attacks, attacking a website. And I'd say when I say learn about them, I do not mean to just learn about them in a theoretical way like you do when studying for a test. You take on paper. You actually do them in simulations. So it's another angle that complements what you learn in class. And there are various tools that you use. For example, you'll use Wireshark, which is a widely used network capture tool, which is actually used in the industry. So it's good to go ahead and get experience with that. And I'll bring up, let's see, I'll bring up that on my screen here. So here you can show the various networks that are available, and you can actually capture actual traffic that's on that network and use it later for such things as analyzing what's going on, analyzing what may be evidence of an attack, analyzing encrypted data. And you also use other various tools such as digital invisible ink, which is a tool for steganography. And steganography is a practice of hiding one piece of data inside another piece of data. Put the picture, you put the input file here, and wherever you want the output to go, and here you put in the encryption algorithm that you think is likely the encryption algorithm. And in some of the cases, some of the challenges, you'll have a message that's buried directly into one of those images. And you have some that are more complicated than that. It's possible that what you get from here is really just one step. And then there's another step after that. So some of the challenges are more complicated than others. And there's also tools like ORFcrack, which is used for using rainbow tables. I mean, that's one thing you'll be learning when you're taking security. I mean, that's one thing, rainbow tables is one thing I learned about in my very subversive security class, which is a way of dealing with hash passwords. And this is one tool that you can use for actually getting around that. And you'll learn about fcrackzip, which is the one I explained earlier, hashcat. You'll learn about network logs. You'll actually have to look at Python code, see what does that Python code do? What might be wrong with it? And so you'll also, one very important, well, I'd say one of the most important things you'll learn is how to do research, because you will encounter challenges you've never done before. And you wonder, what can I do about this? I mean, when you're in the gym, you can work together with your teammates. But when you're actually in the actual game, you cannot ask questions from your teammates. It's a violation of the game's code of ethics. You are on your own. You deal with your own, the research notes that you have and what you can research on Google from that point on. And so learning how to do that research is very important. And when you're done, to demonstrate the experience you have, you can put what you can gather an analysis of your progress and put that on LinkedIn. For example, here is what I put on my LinkedIn page, the fall 2020 and spring 2021, that demonstrates that I was involved in this challenge. And potential employers can click this right here and see what I did. They can look at an analysis of which areas I was doing well in, which areas I was not doing so well in. And it shows that you're expanding yourself, and shows that you have some practical experience in these skills. Well, there are probably some students out there who are thinking, I have no experience in this. I'm just beginning my degree, or I've only taken some basic computer classes. What can I do with this? Well, I'd say take part anyway. The first season I did in NCO, I had no idea what I was doing, but I did it anyway because I figured, hey, I can learn from this. I probably won't get far, but I'll learn from it. I'll be better off than I did when I started. So that's what I did. I mean, my team, we couldn't really meet in person because that was during the height of the lockdown. But we met every week on Teams and discussed the challenges with each other, gave each other advice. Of course, I was the new guy at that time, but I learned quite a lot. So learn from your roommates. Second, learn from doing research. I mean, for example, you have this packet capture traffic that you want, and it asks you, what port is this attack coming on? Which IP address is the attacker using? Well, do some research on how to interpret Wireshark data and figure it out. I mean, that's when you're actually in the professional field, you'll need to be doing research anyway. And so might as well get some practice doing that right now. And also, yeah, you're here to learn, especially if you're very new in it. And I'd say don't worry too much about actually competing with the other teams. Instead, do it, like I said, to learn from it. Ultimately, you're competing with yourself more than anyone else. Last season, my goal was really just to make it farther than I did the previous season. Answer more challenges, get a better accuracy score than I did last time, which I did. I made further and made a better score than the previous season. So I achieved my goal. And of course, that will be my goal this coming fall, make it even further, because there were some areas that I really didn't do much in, such as the web application attacks. I don't think I really did anything in those areas, but I'm learning about those this semester. And so hopefully I'll make some progress on those this coming semester. And I say, so how to approach it? Well, like I was saying, during the actual game, you have to rely on yourself and your research, but during the gym, you can meet with your teammates and learn from each other. And also, very importantly, I'd say during the whole process, keep notes. Right here is sort of an image of my Wikidot page that I've taken, where I've taken notes for my various times on NCL, such as traffic analysis, web application exploitation, log analysis, and so forth. And they've helped me. I took some of those during the previous season. They helped me during the second season, and I expanded them. And so they help you, and they also help you during your career because it'd be good just to have those available. I mean, I use Wikidot, but I'd say use whatever method works for you. I mean, if you find a software that's stored natively on a computer that organizes things in a way that makes sense to you, then hey, use that. You have to learn how to use Google effectively because you will be stumped by things from time to time. A good blog is cryptocate.com, which has a section specifically on NCL. And that's a great resource. And Also, when you're in a team, when you actually in the game, when you enter a question, when you enter the answer to a question, if you get it wrong, it impacts your accuracy score. And so one thing my team does is when we're actually in the group game, if you think the answer to this question is, let's say you think this attack is coming from web IP address 68.200 point whatever, and you think that's where it's coming from, don't actually put the answer in. Instead, we set up a shared spreadsheet where each of us can vote on what we think the answer is. And if we're all agreeing, then we're probably right. And then our designated person puts the answer in. If our answers are all over the map, then we know we need to discuss it a little. We need to try a little. We can't discuss it because we're in the game. You can't really share. You can't really help each other. But if the answers are all over the map, we know that we probably need to work on it a bit more. And then that protects our accuracy score. And to prepare for it, I'd say, aside from knowing just regular security concepts, I'd say become familiar with Linux. I mean, that's something that anybody in IT should learn about, especially someone in networking or security, because you'll need to learn about Linux operating system, know how to do Linux commands. If there's a Linux command you've never used before, know how to use what's called man pages, which are manuals that explain how to do Linux command. Of course, you can also, like I said, do a Google search, learn. There are websites that also explain those commands, YouTube videos that demonstrate them. So learn how to use Linux, and especially learn how to use Kali Linux, which is a version of Linux that's optimized for ethical hacking. And even if you don't have a computer that can hold it as a native operating system, Kali works quite well as a virtual machine. So, for example, I have a Windows computer, but I can run Kali in a window of that Windows computer and do what I need to do. So yeah, it works quite well for that. It also works quite well as a live USB. So it's not difficult to get a running Kali machine, and it's good to go ahead and start playing around with that. So I'd say if you're an IT student, regardless of your concentration, I don't care if your concentration is software development, networks specialists, game development, cybersecurity, you'll find something relevant in it. And so go ahead and get involved. If you're an IT student of any concentration, I encourage you to get involved because one, you'll learn about security, which is definitely a growing concern today, but also it's fun and challenging, and it's a good opportunity to stretch yourself. And it certainly has, I mean, like I said, the first time I did it, I had no idea what I was doing. And I certainly was nervous about, okay, how far will I get? But I'm glad I did it. I'm glad I took on the challenge, glad I stretched myself. And really, I'd encourage any student, regardless of the experience in IT, to go ahead and get involved in it and enjoy it and just enjoy the challenge.
A big thank you to all of our virtual student posters. We appreciate you taking the time to join us today. Thanks.